Assalamualaikum, welcome back again. So today our topic is scalar and vector quantity. So this is the third part of 1.1 where we will learn about both scalar and vector quantities. So what is actually scalar quantity? Scalar quantity has only size or what we call as magnitude. Okay, whereas the vector quantity doesn't have magnitude only. With magnitude it also have the direction, so it is magnitude plus direction. If we talk about examples, if we say the scalar quantity is speed, the vector quantity will be velocity. You learn about speed and velocity, more about speed and velocity and the graphs and the difference between it in the next chapters of physics. But just remember, speed, it has only magnitude, but velocity, it will tell you, like for example, speed is 2 meter per second, but velocity, it is like 2 meter per second to north. So it will give you the direction also. Okay, if we think about other examples of the scalar quantity, we can talk about time. You think, do you see time, does time has any direction? For example, if I say 2 minutes, does 2 minutes have any direction, like 2 minutes to the north, 2 minutes to the south, to a 45-degree? No. So 2 minutes is a scalar quantity. So time, then mass, energy, so these all are scalar quantity. However, vectors are like, as I told you, velocity, we can say weight, because weight is where? Weight is always downward. So weight is also a vector quantity. Then we also have momentum and acceleration. There are more, but I'm just giving you these examples. As I told you that the vector quantities have direction also, so to find a force in vector quantity, it's not that easy. You always have components. For example, if I say that there is force F with an angle theta, okay? So what will happen? It's a direction, right? So this is the vector quantity having a direction in the x-axis and another direction in the y-axis, right? So I'm saying that to find the resultant F, I have to actually resolve for x-axis and for y-axis. So I have to do, the resultant force F is actually nothing but Fx whole square plus Fy whole square. But if we only find the magnitude, will it be vector quantity? No, right? So we also have to find out the angle. So theta is which tan inverse Fy over f of x. Let's see an example so that you will be more clear how to find the resultant and how to resolve the components. So we have known that F, the resultant force, is the component Fx square plus Fy square, root over of Fx square plus Fy square. So I have told that the Fx square is 3 Newton and the Fy square is 4 Newton. So Fx 3 Newton and Fy is 4 Newton. So what can I write? Resultant force F is root over of 3 square plus 4 square, which is equals to 5 Newton. So this is my magnitude. To find the direction, I have to do what? Theta equals to tan inverse f of y by f of x, which is theta equals to tan inverse 4 over 3, which will give me 53 degrees Celsius. I hope you understood how to find both magnitude and direction of a vector quantity.